For this video, I would like to create a function that will return the sum of all of our data in our linked list. So in this case, 10, 20, 30, 40, 50. So here on the right side is a pictorial representation of the linked list that I have in main. I would also like to create a function that will return the average of the data in our linked list. Since we are creating a sum function, it's only natural to create a function that will return the average. So on that note, let's get started. The first thing that I want to do is create a function prototype, and the data type will be an int since we'll be returning an int, and we'll call this getSum, and we are going to have one parameter, and that is a node pointer head. And let me go ahead and copy this and create a function definition. Inside of our definition, I want to create a variable that will hold the sum of all of our nodes. So that way, when we return it, I can just return that particular variable that holds our data. So it's going to be integer, and let's call it sum. And we're going to initialize that to 0. I also want to create a current pointer that will traverse our nodes in our linked list. If you look at the right-hand side, in our main, we have a head pointer. Well, if this head is not pointing to anything, if it's pointing to null, then we want to return 0. We want to return nothing because we don't have anything. Let's target that condition. If head is null, then we just want to return 0. If it's not null, here we are going to use a while loop to traverse to our list so that we can add our data. So while current does not equal null, as we traverse through our nodes, what we want to do is we want to store our data into sum. So for example, let me go ahead and create an activation record in our stack for our getSum functions. So in our sum, we're going to have a head pointer, and this head is going to hold the address of that head, which will be pointing to this head. We're also going to have a current pointer that will also be pointing to this head. While current does not equal null, and in this case it doesn't, we're going to take that data, which is 10, and add it to sum. So currently sum is at 0. What this says is sum equals sum plus 10. Sum is 0 plus 10, so currently this will be at 10. After we store our first node's data in the sum, we want to traverse to the next node. So we want to take this current and traverse it to this node. To do that, we just want to go to current next. Current. So now our current is at next, and so far our sum holds 10. When we go to current next, we go back to the while condition. Does current equal no? Well, no, it doesn't. It goes to line 56, and so far sum is holding the value of 10. This is going to say 10 plus 20 will equal 30, and 30 will be stored to sum. And then current will then traverse to the next node. And then we go to the while condition again. Does current equal null? Well, no, it doesn't. So this condition is true. So it goes here to line 56. And line 56 is holding 30. So this is going to say sum equals 30 plus 30, so now this is going to hold 60. And so we traverse again to the next node, and now current will hold the address of 0x400. And then we go to line 56. Well, currently our sum is holding the value of 60, so we're going to have 60 plus 40. This will give us 100. And then we go to our next node, we traverse through the while loop again, and so far we're holding 100. And so 100, line 56, 100 plus 50, that's going to give us 150. Current will then traverse to null, and then we go to our while loop. While current doesn't equal null, well, current does equal null. So this condition becomes false, and when this condition becomes false, we exit, and once we exit, the only thing that we want to do is we just want to return our sum. Well, let's test this function and see if I made errors so that we can fix it. So let's go to our main, and I actually put this function prototype at the wrong place. And so I'm going to put the function prototype here. Here, let's call our getSum, and we're just going to pass head. And then to print that, let's store it in the sum. Here in getSum, we also have a variable that's an int that holds the address of sum, but this is a completely different scope. And once we execute this function is popped off. We can reuse the sum here because it's a different scope and it won't affect our sum and our getSum function. So now let's print that. I'm going to print it here. So let's test it. Okay, here's our sum, 150. Our function works. Now that we have our sum, let's go ahead and create a function that will give us the average. Let me put the function prototype at the right place. But instead of an integer, we're going to call this a float because we may have some decimals at the end once we get the average. Again, we're just going to pass our head node. And let me go ahead and put this at the bottom and create a function definition for it. So for our definition, this is actually really easy. There are two ways that we can do it. The first way is we can create a variable called average, and we can initialize that to 0. And then on the next line, we can just say average equals getSum. We're going to call our getSum function, and we're going to pass ahead divided by, actually, this is the wrong data type. We want our average to be a float. When we create our average calculation, we have to make sure that we typecast one of the functions to a float. So that way we'll get a float average. Here we're going to say float, and we have the sum. And so to get the average, we just have to divide it to the number of nodes. Well, how do we do that? Well, we already have a function that will count our nodes. So we'll just simply call that function. So we'll call that count nodes, and then we'll pass head. Here, return average. Let's see if this function works. And again, here I'm just going to create another variable in average. And since we are in a different scope, it's okay to reuse average. So we're going to say get average, and we're going to assign our function to that. Let me add a new line at the beginning here too, so that way we can have some separation. So now we want to do printf. And the format specifier, we're going to use 2 decimal places. So you just put a 0.2 2f, and then I want to add a new line here. And then here I just want to say average. All right, let's see if this works. Average. Oh, I misspelled average. And I have an error. Let me figure out what my error is. This should actually be 0.0 because we're using a float. Average getSum, so this should give us 50, and this should give us 1, 2, 3, 4, 5. So 50 divided by 5, and then we're going to return that float. So this looks good. So let's go back up here in our main function and find out what's... Oh, here's the problem. We have to change this to a float data type because it's returning an int, and the compiler is converting it to 0.0. Let's see if that's the error, and let's run it. And there it is. Our average is 30. Okay, let's try to get some decimal values. Let me change it to 7. Finally, there it is. Our sum is 157 since we added 7 to it, and our average is 31.40. There is also another way that we can rewrite our getAverage function in one line. But before I do that, the whole point of writing code is to make it as readable so that your teammate or your team members can look at your code and be able to read it and modify it if needed. I wrote it this way because this is pretty readable, but since we're just getting the average, we know that all we're trying to do is get an average. There is one way that we can write this in one line. All we have to do is return the value that we get when we divide our sum and our nodes, or the number of nodes. And this, in my opinion, is also pretty readable because you know that you're getting the average and it takes less lines. As a programmer, you have to decide whether adding an extra line or two makes your code more readable or not. So let's run this to make sure that that works and see you get the same results. That, in a nutshell, is our getSum and our getAverage functions. Thank you for watching.